Assalamualaikum to my panel Encik Hamzah bin Muhammad Tum and Encik Sheikh Ismail Farus bin Sheikh Zakaria and also my supervisor Dr. Fauzi. Today I will present to you my PSM1 slide about evaluation of ANONNA MURICATA and paper beetle leaves extracts as an eco-friendly corrosion inhibitor for carbon steel in 1 mole hydrochloric medium. For my presentation outline, there will be 3 phases of which is introduction, literature review, research methodology, and expected result. Introduction to this presentation is about corrosions. Most of metals suffer corrosions. This problem can lead to loss of life and economy. This is because the corrosion affects durability of building structure and safety of the buildings. It is invisible and ongoing but controllable. We need to control corrosion makes metal has longer lifespan. For the problem statement, I found that corrosion always happens when the coating barrier of a low carbon steel surface is mechanically destroyed as a result of a microcracks on the surface in automotive, marine, oil and gas and aerospace industries. Organic inhibitors, on the other hand, are the most common used in markets such as chromium, nitrates, molybdates, and tungstens. When it comes to preventing, controlling, and reversing metal corrosion, the use of inhibitor is a well-known method. Corrosion like these are prohibitively expensive, dangerous, and hazardous to both human and environment. Green inhibitors were chosen due to their low cost, biodegradability, ecological acceptability, and renewable nature in light of this challenge. There are 3 objectives of study, such as to study the effects of emission time on the inhibition efficiency of the corrosion inhibitors, to evaluate the inhibition efficiency of ANONNA MURICATA and paper beetle leaf as plant-based green inhibitors for low carbon steel in an acidic medium. Lastly, to investigate the effectiveness of the selected green inhibitor in preventing corrosion on low carbon steel in an acidic medium. There are 5 scopes of study, which is to determine the optimal formulation of green inhibitor for use in the oil and gas industries as an anti-corrosion inhibitor on a low carbon steel substrate. Next, the selection of ANONNA MURICATA and paper beetle leaves as green organic inhibitors to be extracted from them. Preparation of extraction inhibitors derived from ANONNA MURICATA and paper beetle leaves. Next is bandsaw machines were used to cut the substrate material into a 25 mm diameter and 10 mm thickness respectively. Lastly, to conduct mechanical testing on the substrate used as a harness test and optical microscope. For literature review, I will start with type of carbon steel. There are 3 types of carbon steel, which is low, medium, and high carbon steel. Firstly is low carbon steel. Low carbon steel have less than 0.5% carbon content. It is ferrite, perlite, low hardness and coarse, high ductility, toughness, machinability and weldability. Next is medium carbon steel. The carbon content for medium carbon steel is around 0.25% to 0.6%. It is martensite, low hardenability, medium strength, ductility and toughness. Lastly is high carbon steel. The carbon content is around 0.6% to 2.0%. It appears like high hardness, strength, low ductility. For my evaluation, I will choose to use low carbon steel as it is very easy to shape, weldable, and most important is very cheap compared to other carbon steel. There also disadvantage of low carbon steel, of course, as its name is low in strength. Most obvious con of this carbon steel is a low corrosion resistance. Example of application is used in automotive industry, used as middle in pipeline, and also metal gate and or fence. Overview of corrosions. Chemical of electrochemical exposure to the environment cause corrosion, which is defined as metal and other failure to occur. Wet corrosion and dry corrosion are two types of corrosion process that support the corrosive qualities of a given environment. Alloying, galvanic corrosive, and erosion-related corrosion are some of more common types of corrosions. Corrosion can be categorized as either general or localized. So the environment is made up of anything that comes into contact with material. There is a lot of form in corrosion, but I will show you 6 examples of it, which is uniform corrosion, crevice corrosion, galvanic corrosion, pitting corrosion, erosion corrosion, and lastly intercrystalline corrosion. Corrosion is classified on the basis how it appears on corroded metallic surface. Most types of corrosion can be detected with naked eyes, although in some cases high magnification are needed. There are 5 types of corrosion control method, which is material selection, proper design, cathodic anodic protection, corrosion inhibitor, and lastly protective coating. In this study, I will focus on corrosion inhibitor as corrosion protective method. Corrosion inhibitors are chemicals that when added in a small amount to an environment where metal is corroding, slow down, stop, or slow down metal corrosion. A corrosion inhibitor intensifier is a substance that makes an acid corrosion inhibitor works better. The inhibitor is a chemical that sticks to the surface of the metal, called chemisorption, and form a thin layer of protection, or it is a mix of inhibitor ion and metal ion. In this study, I will show the alternative corrosion inhibitor, which is a green corrosion inhibitor that can be found in a natural source or also biomass waste. The usage of a green corrosion inhibitor, for example, has been proposed as a way to prevent rusting in the future. Environmental stewardship is a well-known and growing tradition that uses green inhibitors to protect metals and alloys from corrosions. One of green corrosion inhibitor I will be evaluate is ANONNA MURICATA leaf. In previous study, in a solution of 1 mole hydrochloric solution, an extract of ANONNA muricata leaf was found to be an effective inhibitor of carbon steel. The inhibitor concentration affects the rate of corrosion of carbon steel in 1 mole hydrochloric solution. As the inhibitor concentration increases, this rate decreases. A decrease in percentage inhibition efficiency as the temperature rises indicates that the major inhibition mechanism was vesicle absorption. For carbon steel in 1 mole hydrochloric solution, ANONNA muricata leaf extract is an environmentally friendly corrosion inhibitor that can be used to substitute harmful and costly corrosion inhibitors. Next is piper beetle, or in Malaysia culture we'll call it daun sirih. A piper beetle leaf extract that can be added to a corrosion inhibitor system provide a high corrosion inhibition performance of steel in a 0.1 mole hydrochloric solution, according to previous study. Results show that piper beetle leaf extract at a concentration up to 2000 ppm increase the inhibitory efficiency because of the creation of a compact, resilient, and uniform protective layer. As a result of a research presented here, a new inhibitor for enhancing steel's corrosion resistance by surface treatment is proposed. Here are a table of findings from 4 previous studies. For research methodology, here I will present to you a flowchart of the study. Firstly, we prepare the specimen for the corrosion test. Next, the extraction process of ANONNA muricata and piper beetles. Next is the oven process emission test and FTIR analysis, surface study. Next is analysis the result of the specimen and then the thesis. In the other hand, after we prepare the specimen, we do the mechanical test, which is microstructure and hardness test. For the preparation of material, we cut the specimen using bandsaw machine with the depth of 10 mm for each specimen. For mechanical testing, there are 3 machines I will use, which is optical microscope to create a magnified image of an object specimen with an objective lens and magnifies. Second is metallurgical grinding polishing machine to achieve the flat sample with a little damage of the sample surface as possible. Lastly is hardness test to evaluating hardness strength of a materials when testing extremely tiny and thin sample. For surface study, we use scanning electron microscope to analyzing the material structure at the level of micro. Next is energy dispensive X-ray analysis to identify the element of composition of materials. For the corrosion test, I will conduct emission test that will be set up as shown at the right of the slide. To predict the material resistance of corrosion and evaluate a material behavior in a specific corrosive environments. The sample have been subjected to a corrosion test in 3 different conditions, which is no corrosion inhibitor, with ANONNA muricata, and with piper beetles. The emission test will be carried out by 7, 14, 21, 28 and 35 days in 1 mole hydrochloric solutions. After that, I will calculate two types of formula, which is weight loss and corrosion rate, to determine the effectiveness of these two green corrosion inhibitors. Lastly, to conclude my PSM1 slide, there will be expected result. Corrosion inhibitors by definition are chemicals that will, when added to the solution at low concentration, reduce the rate of corrosion. The effectiveness of the inhibitor is measured in terms of how much this improvement has occurred. The inhibitor will act as a barrier on a surface of the low carbon steel that will prevent corrosion happens on the surface of it. In theory, correlation between laboratory and field performance can be achieved if critical parameters in inhibitor chemistry and corrosion can be identified. I totally expect that the Piper Beetle have better efficiency on corrosion rate compared to ANONNA MURICATA based on previous research. Here are Gantt chart for PSM1, Gantt chart for PSM2, and lastly I include to you the reference. That's all from me. Thank you. Terima kasih and arigatou gozaimasu.